So views are just virtual tables. Okay. A virtual table is, if you remember, when you do a query select statement, it returns some data back. Okay, that data set is a view. Okay, in a select statement, because once you retrieve the data, usually you are done at that point, right? You either print it out and save it, or save it to a file or to a CVS file and so forth, and you're done there. So instead of rewriting that statements every time you want to get the data, you would store that into a view. Okay, so you save the result into a view, and then now that view becomes a table. It's like it's a table that does not store any data. It's just like a that's what it's called, a virtual table. Okay, you can have the exact same fields in the underlying table or the base table, or you can just pick and choose whatever columns you want to get out of that table and then store that view there. So it's just like a window to the actual base table. Okay, and because of that, depending on how you create it, you can actually update data and also delete data and insert data into the base table as well. Again, doesn't store any data unless it is a cluster index. It has a cluster index, then that view now is called, is actually stored the actual data as you do in the table as well. And I'll show you what that looks like in the database. You see the actual data as well as the data size. Okay. So a view is, again, it's just a storage of a series or a list of query selectments, select statements. Okay, it doesn't store other things, just select statements, because that's what you get, a result set. Okay. And because the view looks like a table, you can treat it like a table. You can query from that view to anything that you can with a regular table with a view as well. You can alter it as well. You can change it. You can delete it, and so on. The only thing is that it does not alter the original table. Okay, you can add data to it, but you cannot change its original structure. If you want to change it, you have to go to the base table to do that. Okay. You use a view for various reasons. One is to simplify the data schema. So if you have a really complex statements to query data, usually in the real world you have like subqueries. A lot of subqueries within a query. You have like many layers because you want to get data from a different table, from a different server somewhere. So you can have a really complex statements, and then if you want to get that statements to a user who has no idea what SQL is, then that's a problem, right? So usually you resolve that problem by creating a view. So you simplify everything, and because you already define or design that really complex query, and then you output it to a really simple table, and then you give that simple table, which is a view, to the end user, and they can query from there. So they don't have to understand the underlying scripts in that statement. Okay, so it's to simplify complex schema. It's also filtering sensitive data. This is a very important part for security and privacy reasons. Okay, because sometimes you don't want, let's say, people in the sales department to know anything about data in the HR department, right? So HR, they know your salaries or your contract information, all those stuff there, but the salespeople, they don't need to know, right? They just need to know what's available, the cost, the total sales, and maybe the customer information, but that's it. Anything sensitive, you want to block those out. And by doing this way, by creating a view, then they usually cannot find out the actual table, because the table can be coming from multiple tables. And not only that, you can also change the column names to something else completely. Okay, so that column name is not the actual column name inside the actual table. So you can change that, and so the user can never know. Not only that, you can actually encrypt it as well. If you encrypt the data, the code, then nobody can know, and there's no way to find out, because to decrypt it is almost impossible at all in here. And so be really careful when you encrypt your code. Once you encrypt it, if you lost your actual script, you're done. Okay, you have to like redo the whole thing again from memory, or rewrite the whole thing, unless you store it somewhere in another file or somewhere, right? Which can be hacked and then stolen, as you can see how that goes. So some people just memorize it in their head, I guess. Okay, so the naming convention, when you create a view, is you would use either the VW and the end or the front. Okay, just convention. You don't have to use it, doesn't really matter. But if you see that in the prefix or the suffix, you know exactly that that's a view. It's not an actual table. Okay, so I would just recommend following this convention here. You can put underscore. I usually do that. If you don't, just put a lowercase VW front or back, or you just take the whole word view there. That's okay too. Okay. This can also use the dot notation. That's completely fine too. It's acceptable. This is not a schema. It's just not. It's just a name, because remember, in a name you can use any character you want, right? The dot, the character, spaces. That's completely fine. So it's just a way to how you want to categorize your name. Okay, so here is a syntax for creating a view. One is the very simple one, and the other one is a more complex one. Okay, so the simplest one here is just basically create view, and then you give it a name, and then the keyword as, and then followed by your select statement. Okay, so your select statement is just your regular select statement you have been using up to this point. Okay, query, select, this column or that column from this table, join table A, join table B, and so forth. Okay, so whatever that is. So before you create a view, you want to just test all your select statements. Make sure you get the data you want. Okay, once you get the data you really wanted, and then just attach the create view to it, and then run the whole thing together, and there you got yourself a view. Okay, very simple. And there's of course there's some rules to it, but not that many rules. Okay. This one here is a little bit more complex. It's not that complex either, but it's sometimes you have to do this if you want to encrypt it, or something about schema binding. We'll deal with that later. Over here, when you create a view, notice this one here does not require the column names. If you want to include your column names, you can do that also. Okay, so whatever you put here will override all the column names in your select statements. Okay, if you don't put it here, then whatever is included in your select statement will be used for that view. Okay, so that is the caveat here. And sometimes, like I said, for security purposes, right? So if you don't want the user to know what actual column they are here, you put an alias column name up here. Okay, so the alias will be visible to the view. They try to look for the view. They look at the structure. You have to encrypt it. If you encrypt it, they'll see the actual table. Okay, so when they do a view, you'll get the column come in. The columns, a list of columns here will be visible to them in the results set, and it will not display the actual column from the actual table in here. Okay, and if you want to encrypt your script, encryption here means you don't encrypt the data. You just encrypt this script here. Okay, the reason why is because if you don't encrypt it, then there is a way you can actually see the source code of the view, and then it will tell exactly what table it is coming from, which column you select from which, and where, and so on. So a hacker can actually hack in there, and they'll know your tables and your data, where they're coming from. Okay, so in that sense, it's not very secure. So if you encrypt it, then there's no way to know the underlying statements. Again, when you encrypt it, just make sure you save this script somewhere. If it's a really complex one, okay, save it somewhere in a really secure place, and then encrypt that too, and then you can never get it out, right? But just so you know, you can encrypt your code. With the option here, this one here will treat your view like how you apply the check constraint in your table, so that if you have to insert some data, you have to meet a certain criteria, otherwise you can't add that data to the view. or back to the original table. So it's the same option here. Same thing, we'll do some example there as well. So here's an example of a code. Just say create view, customer phone list, view name, as, and it says select the customer name, the contact phone from the customer's table. That's all. So this part here is very familiar, right? Very simple. Once you created this view, and if it's successful, if no errors, then now you can access the data from the view here instead of from the customer's table. Because the customer table might have more columns than this. Here I only put 3 here, but maybe the customer's table has 10 columns, and you only want to show 3 columns to the end users. So maybe because that's all they need to know, right? So you restrict that to them only, and in this case they can only retrieve this data. They can't insert data because they don't have the rest of the columns. And unless those other columns are set to null or nullable, then they can't answer data. It will say it doesn't work because you're missing some columns. Okay, so give you some security right there. And then when you select from the view, you just do exactly like you did with the table, except you put here, instead of the table, you put the view name here. Okay, and here I can select everything. I select those just 2 columns, just like the regular table. And I can even use the where clause, just like that. So you only have access to these 3 columns here, and that's it. So you can do the rest just like you did with the regular table. If you have 2 views, you can treat those as 2 tables, and you can do joins with them as well. Okay, so you can say select from this view here, join second view table view, and then on those view IDs and so forth. Okay. The only thing is when you do a view that you join 2 tables, you have to be really careful because you cannot have duplicate columns in here, just like you cannot have duplicate columns in a table, right? So when you create a table, you can have duplicate fields. Even though this is a select statement, because we're creating a view out of this, then the columns here must be unique. I cannot have the same column names. Even though you select, if you just run the select statements, it doesn't really care. You can have 10 same columns from 10 different tables. It doesn't matter. It will show everything, right? But when you put it to a view, it is not allowed. You have to kind of pick and choose which one, or you have to give it a different name so that it's unique in that view. Okay, so we'll do some example there. I'll just see how that's done. So once a view has been created, and if you don't remember the actual source code, like the select statements in here, then you can find that out, like I said, because anybody can find that by issuing this command here. Just put sp underscore help text and then the view name, and that will give you the original source code, whatever it was, and you can copy from there or save that and so on. Okay, so that's really helpful. And if it's encrypted, if you try to do this, it would say the data is, the view is not viewable because it's been encrypted. And that you just see the little message on the screen, and that's it. So to encrypt your code, you just issue the with encryption before the as keyword here. Okay, so you say you can do alter, or you can this is for alter, or you can just say create view customer orders underscore VW with encryption, and then as, then the select statements, and that will encrypt your code. And once that's encrypted, you can only go back and undo it. There's no undo button, and there's no decryption either. I'm sure they did that for a good reason. Okay, so it's not reversible. Just be really careful when you do that. Here I'm going to show you already what the alter view will look like. So as you can see, it's very similar to the create view. The difference is just the word alter from the create. Everything remains the same. Okay, we'll talk about that in a minute. Maybe it says that next. Yeah, a little bit later. So updating a view. So when you create a view, if you want that view to be updatable, That means if you want a user to be able to modify data from the underlying table, the base table, we call those, right? The actual table, because you can't really update data in the view unless that view is an index, right? So to allow update, delete, and insert commands in the view, you have to follow a certain rules. Okay. Usually, it's really difficult to update multiple tables, as you can see, right? When you select, when you update a table, usually only allows you to do only one table at a time. You don't say update table A and table B together, do this, right? So you can't do it. But with the view, you can, if you are using a what's called a trigger to help you out. Okay, and again, that's in chapter 15. I'm not sure we'll do that, but that's beyond the scope of this class. But you can. But usually, a single table, you can update, delete, and insert data to the table through the view if you follow certain rules. These are like, for example, if you want to do insert, you must have let's see there, fields in the view and be able to supply value for the view. Yeah, so just say the columns must be available. You cannot have these keywords in there. Okay, if you have like distinct a group by having clause or the union is your merging two separate statements together, right? That's union. So if you have this in there, or if you have any aggregate functions like the count, sum, average, and max and minimum and so on stuff, is not allowed. And you cannot have any calculated columns in there either. So for example, let's just say I have a total column. I have a column called total, and I get that data from the column cost and quantity from the same table. So this is a calculated field, so that it's not allowed. So therefore you cannot update. If you have any one of these in there, then that view becomes only readable. Okay, you can only read from it. You cannot update the data. So just make sure you pass these rules to make it updatable. You can also limit with the check option here. You can say that if you want to insert data to this table or this view, it must meet the following criteria, right? And the check option here is a little bit different from how you would set the check in the original table. You would just use a where clause, and then the where clause has a certain rules, right, conditions, and then you put the with check option at the very end. So like here, okay, let's just say I have a view called Portland area address view as, and I select these fields: address ID, address line 1, city, state ID, postal code, and modified date. So I have about 6 fields from the person that address table, and you have this where clause. If the postal code is starting with 970 or with 971 or 972 or 986 through 989, right? 6, 7, 8, 9. If your postal code meets any one of these rules, then you can insert into the table. Otherwise, you can't. Okay. But for a select statement, it's fair to run this one here. You get a result based on this condition. But when you enter data to it, then you have, if you issue this with check option, then the data insert into that data must meet one of these rules, okay, in order to be inserted into the database table. So if you have a different zip code that's out of these ranges, then you can't insert it. Okay, so this is like a check going like the opposite direction of coming out of the data, going back in. Then you have to put these values in here. Have to meet these criteria using a where clause. Okay, if you want to check these in the table itself, then you would say postal code default, and then like this or that or that or that, right? And the table structure. Okay. For the input from here, you do kind of similar, but you do this through the view. Okay. If the table has its own option or default, then that's a second layer as well. Okay, so you have two layer of check there. But just so you know, if you want to put some restriction, then this is how you do it. So with this view, and if you were to insert this data, if you want to modify this postal code from with the ID of 22 to 3333, so the ID 22 is whatever it is, and I change the postal code from 97205 to 3333, then it'll fail because this postal code is not in this range. Okay, so it will check against this range here before it does any update or insertion or deletion. Okay, so the alter view, as you can see, is very short. The alter view here is almost like a no-brainer because to alter a view, you have to know the underlying source code for the create view. So if you don't know your the original statements, then whatever you do here, if you know the name of the view, you alter it, then this replaces the original view. Okay, you may or may not want to do that, but that's how it is. So basically, you replace everything, replace the entire existing view. It's like creating a new view all over again. Okay, maybe you just want to change, a column name in there, or add additional column name into that view. You cannot just do how we did the alter table. Alter table, add a new column in there, and then the rest is still the same. For the alter view, you have to do everything from the original view. Okay, just add a new column. So there's a lot of redundancy here. And you may ask why. Okay, so the reason is because of this permissions in any dependency formation. So let's just say you create a view out of this multiple tables, and you give that view to all your end users, and the view name is called customers underscore view, right? So that view is accessible to all the users. And you go back and they say, I want to add one more column into that customer view table so all those people can use it. So you alter the table, alter the view, add the new view column, and then so once you're done, just send an email and say, hey, I added a new column to this view, you can use it now. And then all the script that other people use, because once they put in this script, they will always reference the original view, which is called customer underscore view, right? Okay, and you can alter the view using the same name, and so that whatever you do here does not mess up their source code. Okay? If you change the name to something else, then they have to change all their source code as well to match the view name. Not only that, if you just, let's say, delete the entire view and create a new view called the same name, customer underscore view, then you lose all these permissions from all those tables because you only allow a certain user to use that view, and then since that view has been deleted, then you lost all those permissions, and then now the user have no access to that view anymore because now it's a new view, even though it has the same name. Okay, this has a completely different ID, and then to do that, you have to assign all these permissions again to all the users, and so on. So any dependencies in that view will also be lost. Like if you have a, because you can do like. I can't think of this one here. like maybe your join statements and the others that you would use that view in other like subqueries, and you lose that permission, and then you lose all these dependencies. You basically it become a mess. So that's why even though if it's almost like creating the whole view again, it's always safer to just alter that. So you keep everything as is. Dropping is very easy. Just drop view and then the view name. You can drop multiple views at one time with a comma, right? Just like tables. Drop table A, comma table B, comma table C, right? Same thing. And schema binding. Schema binding is another method to lock your tables and columns to the view, so that other people cannot change the table. Okay, if you want to modify the table, then if it's just have a schema binding, then they can't. If you don't do it, then sometimes other users, other programmers can modify the table, and then your view is now messed up. Okay, so if you lock in there, then if somebody try to alter the table or delete it, it'll say, hey, you can't because this this view here is depending on that table or that structure. You can't modify it. If you want to modify it, you have to either alter the view or delete the view first before you can modify the table. So it was for that reason. And also, if you want to create an index view, okay, index view you must create using with the schema binding. Okay, that's required. Otherwise, you can't. Index view or any UDF, the user-defined functions on those views. So there's a view without schema binding, very similar to what we saw earlier. And with the schema binding, it looks just like with the encryption, same place. So the view name, and this is with schema binding here, and then you're done. Only other requirement is that you have to include the two name. Okay, you have to include the schema plus the customer's table, and only two. You cannot put 3 or 4 in the either. So you can't say database name dot schema dot customers. Okay, it only takes 2. Very specific, just a 2. Usually the DBO dot customers, or if you have a different schema with sales dot order details or something like that. Okay, you have to use 2. If you want to include both schema binding and encryption, then you just put a comma here and just say encryption. Okay, so you have both of them in there. And then of course you can make the with check option below that if you have a where clause and so forth. So very easy. And I think this is the last part here is the indexed views. You will hear the term or you see the word materialized. That means it's just like something just up here. But basically it just means data. Okay, you see the actual data, so it will store data instead of just a window to your tables. Okay, because index, remember index stores data, right? Remember we talked about index last week. When you create an index to a view, it's like create an index, except that view has data. Okay, so and then if you do that, then of course you have consume some data, so data storage as well. So it may or may not be feasible, but use it with care. And I mentioned here is usually used with the OLAP system for analysis purposes because you don't really update that view so much, so you keep it in there, keep the data there for analysis. Data that don't change, right? Because when you change data in a database table, then you have to update all the indexes. If you have 100 of them, all those 100 indexes will also get reanalyzed and re-update, and then so that could take a lot of time. You have a huge database system that can take a week, sometimes more. Okay, we're talking about like huge database like Amazon or Facebook or things like that. Okay. And the index views has a lot of rules, as you can see here. It's about 10. I put 10 here, but probably more or less. Okay, so a couple of them is just that it must have schema binding, so you have to put it in there. The view cannot reference another view, right? That means I cannot have a view in a view. Okay, if it's not, you can have, in a regular view you can't. You can have a view and then you can build a view out of that view again. So you have like a 3-layer, right? Which is fine. But if it's an index view, then you can't do that. It's just the view itself and then the other table, the online table or a function. Okay. You cannot do any outer joins. And so on. But and some aggregates are allowed, some are not. And again, this just show. I'm not gonna test you on these, or we don't have to know all this stuff here. But basically, it's just the schema binding, and you can have other views, and it has to be, I think, clustered index. Okay, because it has to be unique. because the view is not unique until you put an index in it. I think it will prompt you to force you to have a cluster index in the view anyway. So basically just those three. The rest are probably more or less, unless you really go into it and then do some really difficult stuff. But that's about it. Okay, so creating index, same thing, just like how you create index for the table, exactly the same syntax, except instead of the table, you put the view name and then the column name to index. Okay, you can do just one column or multiple columns. That's completely fine, just like you did in the regular table. Okay, so I think that's it for this section. So unless you have any questions, if you don't, we're going to go into the SSMS and do some examples.